Have you ever imagined waking up in the 19th century, looking up at the sky and noticing that the sun, the same sun that we know as a source of heat and light, suddenly had a blue hue? Well, that's exactly what happened in 1831, a phenomenon so impressive that it left people speechless, unable to explain how the sun, which had always been a constant in the lives of all humanity, could change color so drastically. And the most disturbing thing of all is that no one at the time had concrete evidence of what could have caused this extraordinary change in the sky. Was it a divine sign? An unprecedented climate anomaly? A gigantic volcanic eruption in some remote corner of the world? The truth remained shrouded in mystery and speculation for almost 2 centuries, until modern science finally revealed the behind-the-scenes story behind this blue aurora that had intrigued entire generations. But before revealing what the researchers discovered, it is important to delve into the peculiarities of that year to understand why the sun turned blue and how this event left profound marks on the economy, the climate, and even the way we now look at our planet. In 1831, reports from various regions of the globe pointed to something abnormal. The sun, instead of its usual yellowish tone, appeared with nuances of blue and, in some places, even displayed touches of purple and green. Just imagine the perplexity of people at a time when meteorological science and volcanology were still rudimentary. There was no internet, satellites, or any advanced communication system to explain what was happening. Even the most respected scientists of the time, who tried to carefully record every peculiarity of nature, did not have enough tools to create a global scenario and reach a solid consensus. This new colored sun lasted for months, attracted the attention of curious people and scholars, but also brought serious consequences. As the phenomenon persisted, changes in the climate began to emerge, putting crops at risk and causing fear among populations that depended on agriculture to survive. Without exaggeration, we can say that there was a climate of uncertainty and almost despair, because when the sun, the source of all life on Earth, changes, the general feeling is that something much greater and catastrophic is about to happen. During that summer of 1831, temperatures were extremely cold for the time, in addition to severe weather conditions that spread across the northern hemisphere. Late frosts ruined several crops, and in some regions, snow fell at completely unusual times. This scenario created a huge economic impact, since 19th-century agriculture did not have as many technological resources to deal with inclement weather. Famine spread to some locations, causing riots and intensifying financial difficulties. Historians report that there was a significant increase in food prices, as the low supply of grains, fruits, and vegetables caused prices to soar in local markets. These stories, however, were fragmented, and each corner of the world recorded only its own experience of the events. No one could put together the complete puzzle to explain, on a global scale, why temperatures were plummeting and the sun seemed to have adopted such an unusual color palette. Even at that time, some scholars raised the hypothesis that something related to a volcanic eruption could be the main cause. However, without consistent data and, above all, without an accurate catalog of active volcanoes and their eruptive activity at the beginning of the 19th century, these assumptions remained in the realm of theories. Even after months, and even years, of the phenomenon had passed, many people tried to find records of volcanoes that could have erupted in 1831, but without reliable documentation, it was impossible to say for sure who was the main culprit behind the sun's blue color. The only thing left was the conviction that a huge amount of ash and gases must have been released into the atmosphere, interfering with the passage of sunlight and causing those colorful effects that attracted so much attention. However, in the absence of concrete evidence, the matter was almost forgotten, preserved only in the official reports of different observers around the world and in scattered notes about what we now know to have been a true global climate disruption. It was only with the advancement of science and technology that this mystery from 1831 could finally be revisited. Contemporary researchers, equipped with equipment capable of analyzing the composition of polar ice in depth, found microfragments of ash that dated precisely to that period. This material contained evidence that directly linked the particles found to a specific volcano, Zavoritsky, located in the Kuril Islands, currently Russian territory. The turnaround was tremendous, as the data matched perfectly, thanks to the precise analysis of the level of potassium and other elements characteristic of volcanic ash. When Dr. William Hutchison, the team leader, confirmed the correspondence between the polar ice samples and the ash from this volcano, he described the moment as a true eureka. There was proof that the gigantic eruption of Zavoritsky had released frightening amounts of sulfur dioxide and solid particles into the atmosphere, finally explaining the strange blue hue of the sun in that distant 1831. Once these discoveries came to light, the scientific community was able to tie up loose ends and conclude that the observed phenomenon was, in fact, similar to what had occurred on other historical dates. A classic example is the eruption of Mount Tambora in 1815, which caused the so-called year without a summer, a period so cold and devastating that it even inspired the creation of dark literary works and increased reports of famine in different corners of the northern hemisphere. Like Tambora, the Zavoritsky volcano caused a drastic change in the composition of the atmosphere, as the dense layer of aerosols released into the air made it difficult for sunlight to penetrate normally. This natural filter retains certain wavelengths and reflects others, altering visual perception and tinting the sun with unusual colors. Furthermore, these gases and particles can remain in the upper atmosphere for months or even years, influencing temperatures and generating a series of knock-on effects on the global climate. Today, with an eye on the future, scientists warn that large-scale volcanic eruptions still pose a real risk to modern society. Although we have much more advanced monitoring systems than in 1831, there are volcanoes around the planet capable of repeating, and even surpassing, Zavoritsky's feat in terms of the volume of ash and gases released into the atmosphere. A supervolcano, for example, could have severe consequences for global agriculture, disrupt supply chains, and cause the sun to temporarily change hue again. The lesson from the 1831 episode is how much we depend on a close relationship with nature and how isolated events have enough power to affect the stability of the Earth's climate. And, above all, science shows us the importance of recording data in an organized way, since only centuries later were we able to elucidate what actually happened in that atypical summer. Too much time for anyone who wants to prepare for possible future events. The fascinating thing about this type of discovery is realizing how the past and the future are interconnected. When researchers find volcanic ash in layers of ice and relate these traces to documented historical episodes, they create a kind of bridge that helps us understand not only what happened, but what could happen again. At any moment, another remote volcano could erupt with such intensity that it would change the global climate, even if only temporarily, and leave us facing a blue sun or climate effects as strong as those of 1831 or 1815. Even though it is easier to detect signs of volcanic activity through satellites and sensors today, we are still not 100% immune to surprises from nature. Therefore, investing in research, continuous monitoring, and mitigation strategies is essential so that our world, now so connected, can prepare for and respond effectively to phenomena of this magnitude. In addition, episodes like this serve as a reminder that our planet's climate is intrinsically dynamic and fragile. And when we add climate change caused by human action to the possibility of large-scale volcanic events, we have a combination that deserves our full attention. Events like blue suns show that we are not as untouchable as we imagine. On the contrary, we are at the mercy of the forces of the Earth, which can mess up our predictions and affect the lives of millions of people at once. But, while this may sound alarming, it is also an invitation to admiration. Nature is incredibly powerful and beautiful in its extreme manifestations, to the point of painting our skies with improbable colors, arousing both surprise and respect for the grandeur of everything that happens around us. And now I want to know from you, what do you think of this impressive story of how the sun changed color in 1831 and how science only solved this enigma almost 200 years later? Do you believe that we could face a similar event in our time and that we are prepared to deal with these sudden changes in the climate? Leave your opinion here in the comments, as it is very important for us to continue this conversation. And of course, if you like this content and want to see more videos about historical phenomena, scientific discoveries and curiosities that almost went unnoticed in history books, don't forget to like and subscribe to the channel. This way, you help us to bring more and more quality information and to keep the community active, always seeking knowledge and sharing new perspectives.